everyone. Thank you for joining us today. I'm Rachel Taylor, and I'm the Director of Security Risk and Trust here at Docker. So the security team is responsible for managing information security. So we set the policies on things like vulnerability management and vulnerability SLAs, governance, risk, and compliance, managing SOC 2, ISO 27001, and product security. So I interface a lot with the engineering team and our wonderful Christian here, who I'll let introduce himself.
My name is Christian Dupuis. I'm a member of the product development team working on Docker Scout. I'm happy to share today's session with Rachel.
Why are we here today? Well, security and the rules around security are changing. So we've seen that executives are being held accountable and legally liable for security breaches, right? And it's not just the security breach occurred, it's overstating cybersecurity practices, a failure to disclose risks, and a failure to disclose incidents either publicly or to investors. And now we've seen some regulation changes occur after that. So the SEC rules on cybersecurity risk management were released, and that actually requires public companies to report material security incidents within 4 days and disclose them on their financial statements, making the whole security process and security reporting much more visible. And then there are proposed FAR updates, which would require government contractors to report incidents within 8 hours of discovery. And those are just incidents that may have occurred. So this is dynamically changing the security incident response process and how we think about vulnerabilities and how we think about how we develop software. And another component of this is compliance. So while the frameworks like SOC 2 and ISO 27001 haven't necessarily gone down to requirements at, a container or an image level, we are seeing things like that in NIST 800 and 190 FedRAMP. So those changes are coming, and I expect the other compliance frameworks to really catch up. Next, we have this diagram, which is kind of a high-level diagram of a CI/CD pipeline, right? So in my experience with working with security and with engineering, your SDLC and your change management processes are where you really have the most friction between the two teams. And why? Well, there's a lot of processes that have to be put in place to kind of keep up with compliance, to, meet your SOC 2 controls and ISO 27001 objectives. And the tools surrounding these objectives don't always meet developers where they work. They're not meeting them during this pipeline. And that's where we end up seeing some of these gaps. So you'll see some gaps here, which really kind of cover different things. So, right, when we're looking at software composition analysis, we're not really seeing that at the image level with a lot of the tools that are available on the market today. We also see, when a PR is merged, we're not seeing your compliance requirements being met here on an image level. Kind of putting together dependencies, software bill of materials. That's another thing that the FAR is going to require. You're going to have to provide the government with an SBOM. And your software bill of materials is really difficult to compile if you don't have all of the components that make up your images. And then vulnerability scanning. Vulnerability scanning happens a lot of times after the fact. So you are finding vulnerabilities too late in the process, and it's causing rework and a lot of different things, and a lot of frustration on engineering teams and adding to that friction between engineering and security. So how does Docker Scout help with this? Well, Docker Scout has a lot of features in these areas. We have image software composition analysis, license compliance. So you can look at not just your what kind of vulnerabilities you have in here, but you can also look at what licenses you need. And this helps you coordinate better with your legal teams and disclose those licenses to your end consumers. Helps put together your software bill of materials, sets policies, and identify 0 days, which I'm going to now turn it over to Christian, who's going to show you how.
Thanks, Rachel. Hey, do you remember this fun weekend a week and a half ago or two when this XZ vulnerability came out and the message that you sent me over? It was about like, hey, Christian, do you know where Docker might be affected by this vulnerability, right? Is there anything that we can do to kind of internally inform our developer audience, like where we are affected? And for a little bit of background, and maybe Rachel, you can chime in here too, this attack was a really sophisticated attack, social engineering, that really highlighted the risks of like modern supply chain security. Well, I'm not going to claim that Docker Scout could have prevented the attack, but at least it gives you visibility it can provide visibility into where you're potentially exploitable. So let me start sharing my screen and show you a couple of the examples. So this is Docker Scout's overview screen, and you can see graphs and policies and things like that, and we can dive into some of these tiles. But where I want to start is heading over to the packages tab here and do a simple package query and say 𝗦𝗲𝗀𝗃. So where across all of my Docker images, and I'm using my tiny demo account here, of course, am I using this potentially affected package? So you can use Scout across all your Docker images, container images, regardless of where you deploy them to, where you push them to, into which container registry, and find packages before these CVEs actually even get disclosed. So you always get this, Rachel called it software composition analysis for container images. So you can find these things out ahead of time. And then with this particular CVE, we went actually a little further and added it to our policy, which is high profile vulnerabilities. So if you were using Scout, there would be an entry here, and I deployed an image that was actually vulnerable to this. And I could click through, and this tab here, My Images, would once again show you all the images in your organization that are affected. And you can go a step further and say, you know what, I'm actually only interested in what's currently running in my production environment. And guess what? There is nothing here. So I have not deployed an image that is vulnerable to this particular exploit into our production environment. And that's just one way of like being really fast and able to kind of, as an engineer or as a member of the security team, to find out relevant information when these 0 days happen. And I want to kind of dive in now and take a step back from this overview here, which you may have seen in other tools like from other vendors around like software composition analysis, and kind of really take a step back and go into the inner loop and show you how a developer can use Docker Scout to make security part of their day-to-day work. So for that, let me jump over into kind of my images here, and let's pick one of the images. This is actually a good one here. So this is my demo application that is currently running in my tiny demo production environment. And this doesn't really look great. I see that is actually violating a couple of the policies that our security organization has defined. So there are apparently copyleft licenses embedded in this image. I'm running this as a non-root user, as a root user apparently. There are vulnerabilities with fixes in there. It actually does violate our production SLA that our security team has put in place, a different policy for production images with different SLAs. And so on and so forth. So you get like, and you can dive in here and take a quick look into all the details. So for example, this is the list of like all the vulnerabilities. Interestingly, which is kind of like when you think about containers and dependencies of containers, there's base images, right? An integral part of your container security is what base images you are using as an enterprise, as a developer. And staying up to date in your base images is crucial for supply chain security. And there's a policy telling you, you know what, you're using an outdated base image here. So let's go to the to our inner loop, meaning onto the developer laptop, and start working with Scout and the Docker tooling to kind of start remediating those issues that we've seen. This is the checked out source code of the image that I looked at in Docker Scout earlier. So I can quickly run a Docker build X build here locally, which effectively is just going to create a baseline for me to take a look at how am I doing from a security perspective. I can run the Docker Scout quick view command to get a very quick overview of how is this image doing that I've built locally on my machine from a security and compliance standpoint. So you can see that we're using attestations here throughout Docker Scout. So an SBOM, a provenance attestation as created by Docker build, especially by BuildKit. And we got a lot of interesting information here. We, of course, see vulnerability counts here. We can see which of these vulnerabilities are coming out of our base image. We see that we're using Alpine 3.14. There is a newer version, 3.19, that would fix a lot of vulnerabilities already. And then we see the same policies here. Again, not an after the fact, like not the developer doesn't have to push images into the CI pipeline or get it deployed. to be actually evaluated against policies and maybe get blocked by security policies very late in the process. So you can really bring this down into the developer workflow. So let's start by looking into how we can fix some of these vulnerabilities. And I think the most impactful one on this particular image, and you can already see this here, a lot of the vulnerabilities are coming out of my base image is to kind of look at what I can do to update my base image. And that's where Scout provides a recommendations command that again takes the attestation data, takes the knowledge of us running Docker Hub with like a lot of public image content usage. And so we've curated a list of like, these are the base images that you should be using. So we know that you're using 314 right now of 𝗬𝗲𝗀. There is a 319 tag that is much better from various kind of different dimensions, right? It's more recent, it contains less vulnerabilities, and so on and so forth. So it's a very kind of like recommended approach to just say, hey, you know what? Let's go and fix our Docker file. And given that I can do this all locally, I can run my tests and everything in my inner loop. So let's update our base image here to 319. Going back to the sorry, Rachel, of course.
I think it's really important just to kind of highlight, like, they don't have to go to another tool. They don't have to go to the Scout UI to see this, right? It's hitting them where they're working without interrupting their workflow.
Exactly. Yeah, that's very important, right? For now, nothing has left my machine, right? All the code, all the work, it was really fast. I can use my IDE and so forth and so on. So running Docker build again on this will now use the updated base image to see quickly how am I doing now. I can run my Docker Scout policy command again, which is a way of like just specifically running policy locally. Again, local image, not pushed into CI yet. You see how the Scout CLI is kind of getting all the attestations, and we can kind of see all the details here. This time we get a lot more detail. We see that there is a particular package that comes with a GPL3 license, which our security team is not really comfortable from a compliance perspective. So that's probably something that we want to address. And there are still a couple of vulnerabilities here that I should take a look at. But before I continue here, I want to just really quickly jump over to Docker Desktop. As part of like the Docker offering, again, on the developer machine here, you can get Docker Desktop. And here's the image that I built locally about 2 seconds ago. And when I bring this up, I get a very visual representation of the composition of your Docker image locally. And it's a very nice way of finding which package came from which particular instruction in your Docker file. So a quick reminder, we are trying to fix this license violation here. So it's interesting for us to know where did this package get introduced. So I can go over to the package tab here and put it into our search and then start navigating through the layers. And eventually I will find a match. And here we go. This is the layer in our Docker file that is responsible for adding this package to our image. So this is an apk add no cache node.js gdbm command, which I'm sure I can find in our Docker file. And right there it is in line number 9 and 10. So let's remove this. And while we're at it, there's another root user that someone must have accidentally deleted here. So let me put that back in, go back over to our CLI and run a quick build. And at this point, I do another policy command to quickly check how this image is doing. Have we actually fixed a couple of things? And this now tells us that everything's green except these 2 vulnerabilities here. And for this, I want to jump over into another Docker Scout command, which is the CVEs command, which is very specific to showing you vulnerabilities. And it is specific in a way that it uses a lot of like really interesting information from our build process, right? From using attestations, SBOM, and provenance. So you can see very detailed information here. What is the exact line number introducing a certain package? You could even jump over to GitHub showing you this is the line on GitHub that is introducing this kind of this package and therefore this vulnerability. So we want to fix the high ones, because critical and high are the ones that our security team does not allow us to run in production. You can see this here, critical and high. So there are 2 violations. And it looks like it's primarily the NPM Express package. And looking through here, I see all the relevant information on how to fix this. So there's 4.19.2 is probably the version to upgrade to. You get interesting information about the scoring of vulnerabilities, EPSS, a very modern way of like looking at prioritizing vulnerabilities and like figuring out what to worry about more as a developer. So I can go ahead and open my application package dependency descriptor, which is in this case the package JSON file for my NPM project, and I quickly can update the Express version to 19.2, go back to my build, and again, run my build. And hopefully at this point, if I did this all correct, I can run the same command again. And at this point, I should have fixed all the critical and high vulnerabilities, which is exactly what I see here now. There's still one unspecified and one medium here, but we'll take care of that in a little bit. Now, as a developer, I'm happy. It's 5 p.m. I could probably go home now. But before I do this, I should probably push this into our GitHub, into our CI pipeline for others to kind of take over the work. Before I do this, I want to show you another feature of Docker Scout. I want to compare my local work against what's currently running in production. And I want to focus on everything that has changed. So ignoring all the things that have not changed. So now we're looking at the composition of the image from a policy perspective, SBOM perspective, or the packages inside of it, and really compare these 2 images locally. And you can very quickly and visually tell as a developer locally, hey, did I actually improve the situation? So let's do this quickly. It's pulling down all the required metadata, running the policy evaluation for the local image. And I can scroll up and I see kind of like a visual diff of the image that I've built and only have on my local laptop compared to the image currently running in our production cluster. I see that I fixed a lot of vulnerabilities. They're all gone. I upgraded my base image. I can see which labels changed. And here are our policies. So our analyzed image, the local image, has all green check marks, which is great. Compared to the previous image running in production, we actually greatly improved the situation. And then if you're a geek and you're really interested in like the nitty-gritty details, you'll see all the packages, how they got upgraded, changed, added, removed. And with these changes, like all the vulnerability changes here, and so on and so forth. So at this point, I'm just going to go ahead and say git add Dockerfile and package JSON and do a git commit, update my base image, and I could do a git push at this point. In the interest of time, I did this earlier. Let me jump over to GitHub quickly. This is the repo on GitHub, and I raised the pull request in preparation for this webinar about 5 hours ago. I'll show you the changes so that no one says that we're cheating. I upgraded the base image. I removed the GPL v3 licensed package. I added the user in, and I updated my Express dependency. So this has kicked off a GitHub action workflow, which is effectively building the image, pushing the image, analyzing the image. And it has given me this Docker Scout policy status down here in my CI pipeline. So again, as a developer, or as my colleague is reviewing this PR, he or she gets an opportunity to kind of go in and really look at like, what is this doing from a security perspective? There is integration in like Azure DevOps pipelines and other kind of GitLab pipelines where you can use the Scout CLI, the Scout CI integration, and kind of like embed Scout into your CI/CD pipeline.
Thank you everyone for joining us today. I hope you got a lot out of this and on Docker Scout and why we're so excited about the product and making kind of engineering and security teams better together.
Thanks everyone. Thanks for your time today.
Thank you.
Bye-bye.